Hello everyone. Today I will be talking about fuzzy retrieval, a model that goes beyond the simple yes or no of traditional search to provide more relevant and ranked results. The problem with classic search like Boolean model is that it's too strict. It's all or nothing. If you search for big data and Hadoop, it will completely ignore a perfect article that just happens to use the word Spark instead of Hadoop. It can't handle partial matches, so you get a big unranked list of results. The solution is fuzzy set theory. This is perfect for search because relevance isn't a yes or no. It's how much question. Fuzzy logic lets us move from abrupt 0 or 1 to a gradual score between 0 and 1, allowing us to rank documents by how relevant they are. The core idea is membership function, written as mu. Instead of just 1 or 0, every document gets a score. A score of 1.0 means it's a perfect match, and a zero point 0.7 means it's pretty good match, and zero point 0.0 means it's non-relevant at all. In our case, mu of ij will be the score for how relevant document j is to our search term I. So, how do we get the score? The model is smart. It doesn't just look for exact word. It uses a built-in thesaurus or a term-term correlation matrix to find related words. This lets the model give a relevant score to a document about Hadoop even if you only search for big data. The second part is how we combine terms. A simple end in the fuzzy logic uses the min function, but this is too harsh. If a document is a zero point 0.9 match for one term but only zero point 0.1 for other, the min function would give it a final score of zero point 0.1. The fuzzy retrieval model uses software operators like algebraic product for n and algebraic sum for the r to get a more balanced and realistic score. An example is let's walk through an example. Here is our query. We want to find documents for term A and B are not term C. To solve this, the model first breaks it down into disjunctive function or disjunctive normal form, which gives us two n components joined by R. The diagram from the textbook shows our query visually. DA, DB, and TC. There are sets of documents for each term. Our first component CC1 is the intersection of A and B. Our second component CC2 is intersection of A and outside of C. The final answer of our query is the total shaded area, which is the union of these two parts. Now for the numerical execution, let's imagine we have already calculated the base course of our document J. It has zero point 0.8 relevance for term A and zero point 0.6 for term B and zero point 0.2 for term C. Then we first calculate the scores of our two components using the algebraic product. For a component 1, A and B, we multiply zero point 0.8 and zero point 0.6, which gives 0.48. And for component 2, we multiply A and not C. We first find not C, which is 1 minus zero point 0.2 and gives us 0.8. Then we multiply zero point 0.8 into zero point 0.8, which gives us 0.64. Finally, we combine our two component scores using the algebraic sum of R. The formula is 1 minus the first score times 1 minus the second score. So we get 1 minus 0.52 into 0.36, which is minus 0.1 minus 0.1872, which gives us mu of query for document J is 0.8128. It gives us a final score 0.8128. This is a very high score close to 1, which means our document is excellent match for the user's query. We would then do this for every other document and rank all them by their final score. So to summarize, the fuzzy retrieval model is a rank search results by degrees of relevance. It works by using a thesaurus to find related terms and then uses softer algebraic operators to calculate a final score. The result is a ranked list that can find partial matches, which is more powerful and intuitive for a user. Thank you for your time. If there are any questions, you can post it in the comments. Here is a sample execution of our algorithm. We take three documents and our query is Indian and mountain or Japan and mountain, which is converted from conjunctive normal form to disjunctive normal form. We calculate the mu values and then for n value we form product and for the r we use algebraic sum and we finally get the highest score for document 2, which has Kalusubai is a mountain in Western Ghats and located in India. Then after document 3 has more relevance and finally one has the least relevance. Thank you.